The first algorithm in deletion is deleting at the front. That is, you are deleting an already existing the first node in an already existing linked list. Suppose if the linked list is not existing, naturally you have to give a message that the list is empty. How do we know that the list is empty? You are deleting from an empty linked list. The value at the header, right link of the header portion will be null, right? That is, first you give the right link value in the right link of the header node as PTR, and if that value is null, it means that you are dealing with an empty list. So let's go to the else portion. So in order to delete the first node, here the first node data is 1, then 2, then 3. So you are going to delete this particular node. So naturally, when you are dealing with deletion, you will come across with the return node algorithm, and that will be mostly at the end of the algorithm. Okay, now in order to delete this node, now presently its value is PTR, right? How do we get the value from PTR, value as PTR? Because we have first assigned PTR as the PTR has the value of right link of the header node, right? Now next, naturally we can get the value of the second node. How do we get the value of the second node? We can get it from right link of PTR, right? This is PTR, and right link of PTR contains the address of the second node, and naturally we can refer it to as PTR1. Okay, now since we are deleting this first node PTR, now the second node PTR1 will become the first node. That means the right link of header node now should contain the value of PTR1. So naturally the assignment statement will be as right link of header node is equal to PTR1. Now suppose in this example we can see PTR is not PTR1 is not null, but if it is null, what does it denote? Naturally it will be the end of the linked list, but since it is not null, PTR1 should have the value of header, that is left link of PTR1 should have the value of header, right? Since PTR1 is not null, left link of PTR1 should hold the value of header, since now PTR1 is going to become the first node. Naturally all the connections between header and the first node has been released, and all the connections between the first node and the second node has also been released, and the data part, together with the data part, the node is returned to the memory with the help of the return node algorithm. So hope you have understood the algorithm. First we have to release all the connections of the first node, and we have to give it to the, and we have to establish the connection between the header node and the present second node, and that is done with this the help of the algorithm. Next we will be dealing with algorithm when you delete a node at the end of the double linked list. Let's take the same example. You already have an existing double linked list with the data 1, 2, 3, and naturally you have to delete the last node, right? So last node which has the data 3. So how do we reach the last node? Naturally sorry, we have to traverse through the double linked list. So starting from header node, you will give the value of header node as PTR, and you will go forward with the help of the while loop. And what should be the condition of the while loop? When until the right link becomes null, you go forward, that is PTR equal to PTR of right link. Now suppose what happens if PTR is header itself, so that means you are dealing with an empty list. Now the else part means you have reached the end of the linked list. So naturally this will be, the last node will be referred to as the value PTR, right? Now how do we get the predecessor node of the PTR? It can be attained from the left link of PTR. So we will assign the predecessor of the last node PTR as PTR1, right? So PTR1 is given the value of the left link, that is the predecessor of the last node can be found out, address of the predecessor can be found from the left link of the last node. So PTR of left link, the value is given a variable, address variable PTR1. Now naturally PTR1 becomes the last node, since we are going to delete this node. So naturally, right link of ptr1 will have the value null, and this connection can be closed, right? And this connection can be revived. You keep the value of a right link of ptr1 as null, right? So only two assignments are done. You give the left link value of the last node as ptr1 and right link of ptr1 as null, and return the node ptr to the memory, right? So next we will be seeing deletion at any position. Now we will be dealing with the algorithm deleting a double linked node in a double linked list at any position. So the position is determined with the help of the key value. In this example, we will take the value of the key as 2. 1, 2, 3. We have 3 nodes with the data values 1, 2, 3, and I will take the key value as 2. So naturally, we will start from the first. We have to start from the header node. The right link of the header node contains the first node, and that can be referred to as a variable as ptr, and you have to traverse through the linked list based on 2 conditions, right? So with the help of the while loop, you go traversing, and before that, if you find the right link value of the header node as null, that means you are dealing with the empty list. So that condition is satisfied in the if portion. That is, if ptr is equal to null, you give a message that saying the linked list is an empty list. Now in order to traverse through the linked list, naturally you will have to use a while loop, and the while loop contains 2 conditions such that either you encounter the data part of the node with the key value, or either you reach till the end of the linked list. So the process of traversing goes forward until you get either of the conditions as false. So the condition will be you go forward until the data value is not the key value, or not or and the right link of the present node is not a null value. So right link of the present node is not a null value means you have reached the end of the linked list. So what happens if you find the key value? As I said in the example, we are taking the key value as 2. So that means the data node containing the value 2 is now referred to as ptr. Now naturally, what happens here is in the deletion process, this node is going to be deleted, right? So we have to have the value of the predecessor node and the successor node. Now I can refer to the predecessor node as ptr1. Now how do I give this value of assignment? Predecessor can be found from the left link of ptr, right? So ptr left link is given the value of ptr1, and the successor of the ptr, that is the successor of the node that is going to be deleted, can have the value of ptr2. And how is this assignment to be made? Right link of ptr can be given the value of ptr2, that is ptr2 is equal to right link of ptr, right? So naturally, now what happens here is we have already loosed all these connections. I have assigned separate values to the predecessor and as well as the successor of the node that I am going to be deleted. Now what I have to do is I have to establish the connection between these two, right? That is, I have to establish the connection between 1 and 3. So what I have to do? Right link of ptr can be given the value of right link of ptr1 can be given the value of ptr2, as well as left link of ptr can be given the value of ptr1, right? So ptr right link of ptr is given the value, right link of ptr1 is given the value of ptr2, and that is done in this step. Now suppose ptr2 is not equal to null, then only this statement can be assigned. That is, if ptr2 is not equal to null, that means we can give the left link portion of ptr2 of the value ptr1. That is, left link of ptr2 is given the value ptr1. Now I can return this particular node to the memory with the help of return node algorithm. And what is the other portion which is not to be considered? And suppose the while loop is exiting with the help of this condition. This condition means you have not found the key value. Then you give a message saying that the key value does not exist in the linked list, and so therefore the deletion is not possible, right? So as a summary, you traverse the linked list based on two conditions. Either you find the key value or you do not find the key value. If you find the key value, you execute the steps in the if statement. That is, you have to release the connection of the node that is going to be deleted and establish the connection between the other two nodes. And then the second condition of the while loop, which implies that the key value does not exist. You give a message that the key does not exist, exit, and the deletion is not possible. Thank you.